So we're going to go on to specular. So there was a lot of feeling that it should be brightest in the direction the light reflects off. Well, that's true for specular objects. So here we have a light. The light is at this vector direction. And we again have our normal. And then we think the light should go in this direction is where it should be shining out from our reflection. And then we have our camera someplace. And if our camera is not in the right direction, then we shouldn't see it very bright. And if it is in the right direction, we should see it brighter. This is what we would like to achieve with specular lighting. So first we need this reflection direction. I think I'm not going to work through the math. This is just vector math, but here is the vector math in case you need to calculate it. For your purposes, if you're doing it in GLSL, GLSL has a built-in function for calculating a reflection direction. And there's a reference chapter in your textbook on GLSL functions. So you can just use the reflect function in order to get this. Or you can come back to this slide and grab this equation if you want to get this reflection direction. And what we'd like to do is now check the angle between our eye direction and our reflection direction. So the same as we previously checked an angle using a dot product, we're going to use a dot product here. So we want something about the cosine between these things. So that's going to be between the eye and the reflection direction rather than in R. We now have eye and reflection. It'd be in L for diffuse. We have eye and reflection for specular. And we have this extra term. We have this specular exponent. So these parts of the equation are the same, right? So my light intensity, I could specify, I could either say my light is the same intensity for both diffuse and specular, or I could say I have separate. The most common is for your light to have a physical intensity, and for these exponents to only be, for these coefficients to only be on the surface. So I might have a shiny red sphere and a diffuse red sphere. So the specular exponent for one might be nothing, and for the other one, I might have a specular exponent. And I might have color in my specular also, since we were talking about that. These might all have color. The typical thing is for the light to be, for each light to have only a constant color. You don't say the light has a blue specular color and a red diffuse color, but the object might be like that. Okay, so we get to this dot product, and then we have this funny term here, right? So this one, this specular exponent. So what does this thing do? Well, cosine is pretty fat. So if we think about our reflection, this is not exactly the scale, but we might have a fat reflection of our light coming off of this surface. What we wish is we could get shinier and shinier objects by making this light reflect narrower and narrower. And we see it here by having a sharp highlight. So when we have a shinier object, we see a smaller dot, and we see a fatter dot when it's a less shiny highlight. So the way we achieve that is we raise our cosine term to a power. So here's to the second power, 8th power, 64th power, right? And the shape of our curve gets like this, so that if I'm more than, I don't know, 30 degrees away, we're just black. And if I get within, then I'm going to get this brighter. So we use this specular exponent in order to get this scaling of the dot. So here's examples. Here's changing the coefficient for the specular coefficient. So the diffuse term is kept the same in all of these pictures. So the fact that I see a gray sphere back here, this is all coming from diffuse. Now I'm turning up the power on specular, meaning the amount of shininess. And that makes my dots brighter. And then as I change this in specular exponent, I get a smaller dot versus a bigger dot. And the idea, you may or may not buy this, but this is classical graphics think, is that these look more shiny, these look less shiny. So you get brighter dots the more shiny a surface is. This is the idea that we're going for. So here's our same rendering again with specular added. So we have diffuse underneath, and these bright dots are being added by this specular term that we just added. So again, let's look at our equation. Our equation is we're going to care about the reflection direction and the eye. And that's going to tell us how much power is coming out of this specularly reflected light.